All right, hello everyone. This is Abe, and here is my project for WPI Data Science 3010 final project. Worked together with this with Nick and Sam, but I'm here presenting this by myself. In the top left, you can see the GitHub, and then also check out my website, which is in the description for more details about this project. So yeah, let's get started. So there are two tasks for this project. There's first task one is business category classification, which is predicting like what type of category a business is. So is it a restaurant? Specifically, is it an American restaurant? Um, Maybe Mexican restaurant, or is it like a nail salon or a hair salon? Then second task is business closure prediction. So will a business close? Yes or no? So for each task, we take you through the solution, the pre-processing, the training, evaluation, and conclusion. So for task one, so our solution is to use a fine-tuned BERT model. So BERT model is really good with text, so we take in the review data and analyze that using BERT, and then give output on the categories. So for the data set, we use the entire Kaggle, it's on Kaggle, the entire Yelp data set, which is 150K businesses and almost 7 million reviews. And we're able to do this because we use the WPI high performance computing server called Turing. We're able to use GPUs like H100s, A100s, and we have access to more memory. So here's the pre-processing. So like I said earlier, 150K businesses, 7 million reviews. And yeah, so we eliminate businesses under 30 reviews. We want more, well-documented businesses that have good reviews, bad reviews, reviews about, the food, stuff like that. We also remove categories outside of 15 and 30 most common. It's hard to predict, very niche categories, and there's not that many training examples for those. So the categories, like for example, restaurant is the most popular one, but it decreases exponentially for each lower frequency category. So those very uncommon ones are very hard to predict. So for the text data, for the reviews, we do cleaning, like removing stop words, punctuation, HTML tags, etc. We also extract the nouns from the review text. So for example, if we're reviewing for a Mexican restaurant, it might extract like, taco or burrito or Mexican itself, which is useful for predicting the category. So using these nouns, we create 512 token packets of words for each business. This is randomly sampled from all the nouns, and 512 is because BERT takes in 512 tokens. So this filters us down to about 40K businesses and 100,000 packets of nouns. So the data structure looks like we have a business, we have the packeted nouns, and then we have the categories associated. So for training, we do an 80-10-10 split, and we stratify by label. So we use this library called ItterStrat Multi-Label Stratified Shuffle Split, which is not part of sklearn or any popular library, but it's difficult to split to make even categories, even like percentage categories, and train, validate, and test, because each training instance has multiple categories. So this is kind of like an optimization function where it tries to make it as even as possible. And it's not part of sklearn, but we had to find this on GitHub. So then we do different, removing anything outside the top 15 categories and 30, and then different number of packets. And we trade it all for 4 epochs. So this gives us 6 different BERT models, so 2 times 3. Here's the evaluation. You can see the accuracy, precision, recall, and F1 scores for both 15 and 30 categories. So yeah, what does this mean? So high accuracy across all the models, that's pretty standard. It's because accuracy does not take into account what we do wrong, so that's why it's so high. The 15 category does better, which means that we do better on more popular categories like restaurant or like American food, stuff like that. And the one packet data set does better. So yeah, in all, it does pretty well. We could fine tune it a little bit more for underrepresented categories, like I said, but that's not important. That important. Yeah, so this can be used to help Yelp automatically better assign categories. For example, if it has a restaurant category, it should also have food, but not all of them do in the data set. So this could help them do that. So on to task two, which I mostly worked on. So how can we predict if a business will close? So we want to, first of all, take the businesses that closed before COVID because COVID, you know, closed a lot of businesses for financial reasons and stuff like that, and that just throws off the data. So we use the review data and we reduce the text length, but then we also take into account other data like the other attributes of the business. Like we calculate the return customer percentage, which is what percentage of customers are return customers in the reviews. We take the average rating, franchise score, which is how much of a franchise is this business. So as you can see in the graph, most of them are just like, franchise score of 0, so like one-off businesses. But then some are at the top end of the spectrum around 10, which are like, the McDonald's, the Chipotle's, stuff like that. And we take the log to make it a more better distribution. So you have like the, 1 or 2 stores, you have like maybe 10 to 100, and then here you have like the 500 plus. Then we also take the location density, so we use Gaussian kernel density estimation to find how close it is to the other businesses in the data set. So as you can see here, this is Philadelphia, and you have the high density of businesses area, which is the red, and then the blue are kind of on the outskirts, the lower density areas. And then we also save this as a parquet for efficient, file storage. So here is some sample text. Amazing, come again, yummy, and with such positive sentiment, hopefully the business will stay open over time. So what does the model architecture look like? So it's a BERT model for the text data for the reviews, and then we combine that with a dense neural network which processes the numerical features. Like I said, the review average rating, the return customer percentage, franchise score, stuff like that. And then we combine that output in the final prediction of in the final DNN, and then an output of yes or no. So we trained this for 15 epochs over 2 hours. So we use explainable AI, the SHAP library. So instead of just predicting if a business will close, we predict why. So it was difficult to get working. It usually can tell within text like which words determine that, but because we used a hybrid model, it was difficult to get working. So we're able to see that text had a big factor in if a business was predicted to close or not. And then second, this little dot over here is average reviews. So maybe high reviews is like most likely to stay open, and then the other features were towards the middle. So the model had an accuracy of 60% with those two F1 scores. So it's not very good. What we did do to increase the performance slightly is do a stratified sampling for the data set. So taking 50% will close, 50% will not close. We also duplicated businesses to increase the number of training examples. So, for one business, we take, let's say we concatenate all the text together, all the review text, and then we split it up into 512 token, packets, I guess we can call them again. And then we pass it in multiple times. And then we also normalize values in the data, and then use L2 regularization. But yeah, in the end, it wasn't that good, but this might be due to just the nature of the data. Like, it doesn't tell us about financials, there's just plenty of factors why a business will close. Like, it's not family member gets sick, etc., that just reviews and metadata cannot capture. So who can use this? So this can be used for risk assessment. As a business, you can see why you're at risk. Maybe it's your location, maybe it's the reviews that are so negative. Maybe it's that, a small franchise in a certain area will not do well because it's surrounded by like a lot of big franchises like McDonald's, Chipotle, something like that. It can also be used as an investment tool. So you can give this to investors and see what type of businesses are likely to stay open and are good investment. Maybe franchises, high density urban stores, or you can see different states. And yeah, customers can just benefit from improved recommendations. So we can also still improve the SHAP to use the text data individually as instead of text data as a whole to tell you know, which words in the text would lead to more likely to close, which would lead to less likely to close. Like positive words might lead to less likely to close. And then also increasing performance. Like I said, L2 regularization, dropout layers, more training data, which you've all implemented, but maybe doing a little bit more. So yeah, that's our presentation. Thank you.